Okay, so what is everything that you can tell me about elements and their placement on the periodic table? Oh, okay, all I heard was an amount of electrons. What about it? Okay, protons can't help you with the charge, though. What elements, or excuse me, what particles determine an element's reactivity? You got three choices. Which particle is it? Well, what is the negative one? Okay, because electrons are either gained or lost. And when that happens, you form an ion. Okay, so for element 19, which is potassium, you can't change the number of protons in there, but you can change the number of electrons because since potassium is in column 1, how many valence electrons is that? 1. See, this is why we probably don't do so well, because when we're reviewing and going over these concepts that you're responsible to know, we're looking at our neighbor, we're doing other things, we're not listening to what it is we're discussing, and that's what gets us in, I'm not saying trouble, but that puts you behind in where we want you to be. So, potassium being in column 1, why is that important? Okay, so that one valence electron then gets lost. And if it bonds with chlorine, a non-metal, what type of bond is that, a metal and a non-metal? That's an ionic bond, okay? Because now potassium has lost that electron, it now has one more proton than electron. So it is now an ion, which means it's got a positive 1 charge, okay? So if electrons aren't completely transferred, like in ionic bonds, if they are shared, what type of bond is that? Covalent. That's a covalent bond, okay? And if you are given a formula with just 2 elements in it, like magnesium or hydrogen and chlorine, what type of formula would that be? Is that a binary compound or a tertiary compound? Yeah, 2 elements means it's a binary compound. Okay. So moving forward then, this is about where we left off with, correct? Okay. Covalent bonds, they can be multiple bonds. And look at this, carbon and nitrogen can form double and triple bonds. So again, this is where we left off with this. Anytime you have an electron that's by itself, you are illustrating that it's trying to form a bond. Okay? So do you have this handout? Okay. We're recording this, so you can go back and watch it if you prefer to do that. Okay, so here we go. Writing formulas and naming compounds. We just established this. Elements in column 1, like potassium, have a +1 charge. Why is that?
Because it's in the first column.
True. So how many valence electrons is that?
1.
Yeah, so that 1 electron is lost. Isn't that right?
Yeah.
So why is that important? I know that's a good question. That's why I asked it.
So I can give away 1?
Did we already mention potassium once or twice already?
Yeah.
We have. So what did we say about it earlier?
1 valence.
It has 1 to give away.
Okay, so again, this is what gets us in the predicament that we're in. Because 1, I don't know, I guess if it's not important to us, well, I guess keep going down that path. We don't want that for you. Okay? So why are calcium, magnesium, and beryllium and strontium? They're in column 2. Why do they have a +2 charge? Because they have 2 valence electrons that get donated. Okay? So what are 2 elements in column 3? That's 1.
Aluminum.
And aluminum. Aluminum especially, it's got 3 valence electrons, so that's why it is a +3 charge. Why don't we discuss that with elements like copper or chromium or cobalt, because those are transition metals or D block elements. They have more than one charge. Okay? And here's, we can see carbon can form, as you can see, a plus 4 charge because it's in the fourth column. It's got 4 valence electrons. Okay. We don't have a whole lot left to discuss. But moving forward, does everyone have this content that wants it?
Yep.
Okay. So notice in here we have positive ions because they're losing electrons. Then for the most part, what do we see here? Now we're no longer forming positive charges, but rather negative charges, with the exception of polyatomic ions. We'll give you an example of that later on. Could say in the show or in our discussion. Yes?
How come every, like, okay, so obviously 5 valence or whatever you want to call it, has 5 plus charges, but what about oxygen? It only has -2, but it's in the 6 column.
So how many more electrons would it receive to make it full?
2.
That's why it would be a -2 charge. Because then it would give you 80 electrons at its outer energy level. Okay, so we're not quite communicating here. Because you had to ask about oxygen, right? Okay, so when you look at that then, okay, and we can illustrate that, we know, okay, what's the atomic number for oxygen? Okay, so we know it's 1s2, 2s2, and then 2p what?
4.
Okay, so right now that oxygen element is neutral, correct? Because it's got 8 positive charges, 8 negative charges. Well, how many more electrons can this hold until it's full? Okay,
How do you, like, it's already at 8. How is it?
what's already at 8?
Oh.
2p6.
Yeah.
We're talking about not all of them, just this outer energy level. It's got 6. It's also in the 6th column. Right. So, for instance, okay, what element is that?
Hydrogen.
Okay, and then what happens if hydrogen loses these electrons, which it does, okay? This outer energy level is now full. It can only hold 8. So it's got 4 and 2 is 6, and 2 more gives you 8, okay? So it still has these 8 positive charges, but now 2, 4, 8, 10, right? That's why that -2 charge is there, because these electrons from this hydrogen went up to here, and therefore you said column 6 for oxygen, right? Just these 2 and 4. Okay, those are its valence electrons, and then we can put a hydrogen atom here and a hydrogen atom here. This one and that one. So now this is a very stable molecule because this formed an ion and so did this because it either gained or lost electrons. Now we went through that really, really quick. Okay. Front row, does this make sense so far? Second row.
Yes, sir.
Third row.
Yes.
If you're nodding your head yes, which everyone did, you are informing everyone around you and myself that you understand this. All right.
How come it isn't in the second valence function or whatever? Because, like, valence, I don't know how to say it. But, because it only has -2. It can only hold -2 charge, but all the other ones can hold 6 charges.
Like, for instance, what? Well, that's because these atoms are a lot bigger than what oxygen is, though, too. Okay. So column 6, where oxygen is located, it would form a -2 charge. Okay, what are these specifically called? Column 7.
Halogen.
Those are your halogens. That's right. Okay, with the exception of astatine or AT. Okay, so transition elements, like what we just said. Tin can be +2 or +4. Barium can only, not barium, bismuth can be +3 or +5. Those are elements that have more than one type of charge or oxidation state. Okay, so an oxidation state just means that's the type of charge it has. If it gained an electron, it's -1. If it lost an electron, then it's positively charged.
I don't know Roman numerals. Yeah.
What about Roman numerals?
I don't
I'm actually starting to understand them. You know what I mean?
Okay.
1, 2, 3, 5.
Well, 1B is 4, and then B1 is 5, and then B11 is 6, and then B11 is 1.
I didn't ask him if B is 5.
Yes.
He
Really?
said B1 is 5. B1
Oh, I said B1 is 6.
He said B1 was 7.
Oh.
Stop talking and don't
Okay, if I'm not mistaken, this is it because the rest of the content is given to you, correct?
Yeah, but actually there's one. There's one.
Okay.
50 is X. I know.
You got to tell me, can we move on?
Because that's the
No. Okay.
Yes, you can do that. I'm about to make your daddy. Uh-oh.
Okay. So then notice, like for instance, this is one element with one distinct charge. One element with one distinct charge. Halogens, one lone element with one distinct charge. How is that different than what we see here? In other words, PowerPoint, you can't put subscripts in there. Okay? How many elements are in this ion?
2.
But it forms a -1 charge. How many elements are in this ion?
2.
There's 2 elements, but how many atoms though? Why would we say 4? Because there's how many nitrogens? How many oxygens? Okay. Then how many atoms are in this ion? 3 oxygen, 1 carbon. 4 atoms. Then what about phosphate then? It's got 4 oxygens and 1 phosphorus. But together, okay, when more than one element forms an ion, that's what this is illustrating, and forms a -3 charge. Okay? Remember, one of the things that we had said is that once you get past carbon, we say typically they're supposed to form negative charges. But the exception to that was this: except in polyatomic ions. And that's what all of these are. Okay? Phosphorus typically forms a -3 charge. But if it's in a polyatomic ion, it actually forms a +5 charge. Okay? Carbon, okay, typically forms a +4 charge. But in this case, and that's what that is, sulfur can be +6 or +4. But you don't need to know that. We're just telling you what that is. Okay? Because typically they form negative charges, but if it's in a polyatomic ion, it can form a positive charge. Now, this is one of those aspects to where, again, it's hard to visualize this until you write it down. You can write this down all you want, but until you actually see it and put it to use, it probably doesn't make any sense. Okay? So one of the things you might want to do is ammonium is the only polyatomic ion that we're responsible for with a positive charge, and it's +1. And the formula for ammonium is 1 nitrogen and 4 1 nitrogen and 4 hydrogens. That is the ammonium ion. 1 nitrogen, 4 hydrogens. Okay? What's the formula for ammonium? 1 nitrogen, 4 hydrogens. What type of charge does it form? Plus 1. Okay? All right. Does everyone have this content that wants it? Okay. You can hang on for just a moment. All right. So who's responsible in here? Okay. So since that is the case, what I want you to do, you said we're responsible. I'm going to pause this, and you're going to come up here and illustrate the sulfate ion. So discussion is continuing. Why can we substitute lithium for hydrogen?
Because they have the same charge? Or the
Not only that, where's lithium located? Right below it. It's in the same column. So when you approach these, okay, typically you want to start with carbon. If carbon's not present, then maybe nitrogen. Okay? Then if neither one of those are present, find the one atom in there that is the least in number in the formula. This means we've got 2 lithiums, we got 4 oxygens, and we got 1 sulfur. What is the least number of atoms? Sulfur. And what column is sulfur in? Okay? And this is what we had said in class. I can almost guarantee you that some people are going to choose to do something like this. Okay, so if that's what we're going to do, you're going to do this.
I said I would never do that.
Mr. McKay, the only thing I don't understand is when you do something with more than several charges. Like, because when we do chlorine all the time, I know we go down to -1, but on other problems like carbon, would you go down to -1 again too?
For which one are you referring to now?
When we do chlorine, usually
Chlorine only has 1 negative charge, and that's ever. That's all it ever has is just -1.
yeah. So you don't ever use +7,
No.
+5. You don't ever use,
Not at this level, no.
and then for carbon, the same thing. You only
Probably only going to ever use +4.
You're gonna use only +4.
Probably, yes. Okay, so we've taken care of our sulfur, and we can put an oxygen atom here. What column is it in?
Oh, 6. 8. Oh, no. 6.
Okay, so that takes care of 1 oxygen. We can put another one over here. Okay, now we're going to form what's called a covalent bond. Put one down here. And we can put one up here. Okay, we've accounted for every atom.
Now you need 2 lithium.
Okay, and we'll come back to this lithium. But what is this polyatomic ion? It's sulfate, right? Yeah, sulfate. You can look at your last page of your handout. It says SO4. It's called sulfate. And
Has -2.
if we do this, there's an extra electron. There is an extra electron. There's no other elements being bonded to that. So it's got 2 more electrons than it does protons. What does sulfate have for a charge? -2. So that's where that comes from. Okay? Because it's got these triangles on here, which are 2 more electrons than it has protons. So that is the ion. It's a polyatomic ion. Sorry?
Would this be stable now then, with the lithium then?
It will, yes.
But it's not.
But we haven't done that yet. Now, once we do this, what column is lithium in? So we can put a lithium atom here and a lithium atom here. This is now stable. It got its extra protons that it was looking for. Because this has a -2 charge, what does lithium have for a charge? What's the least common multiple between these? Okay? Is it 1 or 2?
2.
What is 2 divided by 2? So this sulfate ion acts like, very much like this. Okay? -1 plus 1. That is a monoatomic ion. Halogens do that. But when you put 2 atoms together that act like 1 charge, that's why we call it a polyatomic ion. Okay? So if this has a -2 charge, which it does, the least common multiple is 2. 2 divided by 2 is?
2. I'm at 1.
Okay? 2 divided by 1?
2.
2 divided by 1?
2.
Okay? The answer that you get is what you put down below. Okay? So maybe something a little more complex. Okay? In other words, does anyone think they know? Oops, not that.
Sorry.
Yes?
Would you be wrong if you drew that where you had the sulfur and then the 3 oxygens and then an oxygen connected to a oxygen and then 2 lithiums side by side?
Anything other than this is wrong. Anything. Okay? Okay. In your handout that you wrote down, it talked about tin.
10, yes.
Tin has what type of charge?
This way, I think it's +2.
+2 or
+3.
or +4. It's +2 or +4. The Roman numeral tells you what the charge is. What does iron have for a charge? +2 or +3. Okay? Why do you suppose these Roman numerals are here?
How many charges?
Okay? Now, this is human nature. This is going to happen. You can laugh if you want. We've already established that people are not going to associate this compound with how we want you to draw it. This will happen. That we're going to take that off, someone's going to do that, and they're going to put another oxygen down here. You laugh, but someone will do that. It's human nature. Okay? So if we don't know what the charge is, you have to be told that. That's the significance of these Roman numerals. So, what is the symbol for iron? Fe. Okay? What is the symbol for the oxide ion? It's just a monoatomic. It's just O, or oxygen. Okay? What's the charge of oxygen? What's the charge of oxygen? Can you just please wait until we're done?
He asked if I could have some, and he said he could have some because they're family size, and he said he called me daddy sometimes, right?
I guess. Okay, so when you look at this, we know that the oxide ion has a charge of -2 because it tells you that in its box. But you don't know what iron has for a charge. It's either +2 or +3, correct?
Yep.
Okay, so we're not guessing here. What is the charge of this iron?
+2.
Does this add up to 0?
Yes.
Okay, so for this one, what is the symbol for iron? Okay, What is the symbol for the oxide ion? Okay. What's the charge of oxide? What's the charge of that iron? That does not add up to 0 like it does up here. In other words, this is in hemoglobin. Iron is the ion that your oxygen binds to in your body. And when you donate blood, if you choose to do that, they will take a needle, they'll stick it in your finger, and they will do a test of your iron levels. If this is low, that means you're anemic for that day, and they probably better not take your oxygen. Yes? Or your blood.
I'm sorry. When you're doing a formula and it includes two different ones that have the multiple charges,
Okay?
Can you just pick the charges that match each other? So like if you pick the one that has a -2 charge and the other one with a +2 charge, since it equals each other, you can just do that?
Depends what it has for subscripts.
Okay.
Okay? So what is the least common multiple between 2 and 3? The answer that you get tells you what to put below. Okay? So you could say the same thing that we did here and the same thing we did here. 2 divided by 2 is 1. 1 divided by 2 is, okay? Same thing here. What is 6? You don't have to do this, but it just helps you out. What is 6 divided by 2? What is 6 divided by 3? This is what is known as rust. When steel or iron is exposed to moisture, it begins to rust. That is the difference between these two compounds.
Is that an unstable bond or
Oh,
is that
no, it's stable.
It's unstable?
It's stable.
It's stable.
Okay. So I want you, the last thing, on the front page, N2 or C2H2? C2H2. Who wants to see H2? That wasn't even a selection. Oh, you want to see H2?
No.
Oh,
Hand down.
that's the easiest one. That's what we should do.
No.
But you said H2.
I thought I heard that.
You did. I said C2H2, but you said no. Let's see H2.
I think I like C2H.
I think we should do C2H.
Okay.
We should take that.
This human nature that we're talking about, some people are going to do that. Why? Why are we going to see this?
Just people that pay attention to it.
Because they're going to look at this Roman numeral and they're going to say, oh, that's what belongs down there. Don't do that. It's the charge. It's not the number. Okay?
So is it charged for iron or is it charged for oxygen?
Charge for iron. Oxygen only has one distinct charge, -2. Okay. So how you approach these? Is carbon present?
Yes.
Just show you the right way or look at the approach that you might take?
Right way.
Okay.
Yeah, what Brinley said.
Dude, shut up.
Okay. Carbon's in which column? Carbon's in which column?
Fourth.
Okay. So either on the top or the side, put an extra dot. On the top or the side, put an extra what? Because remember, these are in column 4. 1, 2, 3, 4. 1, 2, 3, 4. You've accounted for your carbons. We have the hydrogen to go yet. What column is hydrogen in? Okay, so how many electrons does hydrogen have? Okay, so does this carbon have 8 around it?
Yeah.
It does. You don't have to put these boxes around here. Some people choose to, that's fine. There's 8 in this box. What about this carbon? Does it have 8?
Yes.
It does. Okay? And then this is something that carbon can do. It can form a what bond? It's a covalent bond. What type of special covalent bond? Triple. There's 3 of them there. It's a triple bond. Okay, so tomorrow we'll have time to work on these. You'll have worksheet 3 handed out. This one's due on the 15th. The other one's due on the 16th. Okay, if you are having problems, what is your responsibility? responsibility to do? Ask questions. You need to take that initiative. All right. We'll catch up to you next time.